Alright, so let's do our review on arithmetic and geometric sequences and series. So hopefully you'll have these formulas memorized. Remember, you can always use the zero term formula, which looks like either a linear equation in slope-intercept form or a exponential function if it's geometric, or you can use the first term. It's up to you. I kind of go back and forth. So find the 100th term of this arithmetic sequence. So we look at this. We see the common difference here is 3. So D is 3. So now we know D. N, well, we need to find the 100th term. So N is 100. And the 0 term means we got to go backwards. So if we subtract 3 from 5, we end up with 2. So there's our 0 term. So the 100th term is equal to 100 times 3 plus 2. So now we work that out. We get a sub 100 equals 302. All right, so let's take a look at number 2. So number 2, they give us the first term, that the nth term is 163, and that the fifth term is 19. So if we need to figure out n, we've got to figure out that common difference first. So since this is an arithmetic sequence, the first thing we can do is think of it this way. Well, our first term is 3. Don't know our second, third, or fourth, but the fifth is 19. So if we do 19 minus 3, we get 16. So there's a difference of 16. Then we have to figure out how many terms forward we have to go. 1, 2, 3, 4. So that's what we have to divide by. So 16 divided by 4 is 4. So our common difference is 4. So now we can say, well, we know that the nth term is 163. We don't know n, but we know that d is 4, and that means the 0 term has to be a negative 1. So we add 1 to both sides, and we get 164 equals 4n. And then we divide both sides by 4, and we end up with 41. So the correct answer would be D on that one. All right, so with this problem here, we got on the first of every month, a library receives a new shipment of 575 books. They started with 3,000, and they receive a shipment that month. How many books will they receive at the end of 3 years? So they're actually going to get 36 shipments if we look at it this way from 3 years. So we know that, think of it this way here, that the n is going to be 36, so it's 36 months. The common difference is going to be 575, and then, well, our 0 term would just be the 3,000 because they still get that first shipment. So if we plug all that in to our calculator, we end up with 23,700 books. So in the first year at local college is $4 grand. The tuition increases 600 a year. How much will the tuition be by the 10th year? So you need to be careful with this problem. A lot of people might look at this and say that it's B, but that is not the correct answer. So if we take a look at this here, we can say, well, close that out. We know that the n is going to be 10, so we're looking for the 10th term. So we get 10 times a common difference of 600 because it goes up $600 a year, and the 0 term is going to be 3,400 because we have to take 600 away from the 4,000. That's the first term. So we plug this into our calculator. We end up with 9,400. All right, number 5. So number 5 is talking about number of bricks that Jenny needs. So this is a summation problem because we have to add up the number of bricks in each row. So we know the first row has 8 bricks and the last row has 24, and we know there's 6 rows. So we can just fill out this formula. So we got S of n equals n is 6 because there's 6 rows, A1 is 8 bricks, and the nth row has 24 bricks, the 6th row. So if we do 3 times that, we end up with 96, so a total of 96. All right, so I hope everybody gets 6 and 7 right, so hopefully you remember how to do this. So what we need to do here is turn to our calculators. We can do all this on the calculator. So if you remember, if you're at the home screen, you just hit math and just hit up 3 times and you end up at summation. Press enter on that. And then we just have to put in the information. Remember, we always need to use x even if x isn't the variable named. Oops. So now we're starting at 1, and we're going to go up to the 10th term, and our equation is going to be 7 minus 2x. Let's press enter. Negative 40, so the answer would be C. Looks like my board's already getting off here. So now let's take a look at number 7. Same thing, math, up, 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 enter. This one we're not starting at the first term. We're going to start at the 11th term and go up to the 30th term. And then it is x cubed plus 2. So let's see what the summation of this one is. 213,240. So that would be B. So hopefully we won't have any issues with those. All right, so number 8. So Ming is a financial advisor, and she gets $43,000 for her first year and gets a 3% raise annually. So this is, if you want to look at it like an exponential growth problem, this is a geometric sequence though, because it's discrete. We're not connecting the dots. She gets that raise once a year. So this is a discrete function. Remember, discrete just means we don't connect the dots. It is not continuous, and we want to write it out as a sequence. So with this sequence, we know that our first term is 43,000. And notice, I don't know, typically I like to always use the first term for the geometric sequence. And we're looking for the 35th term. So we want to know how much she makes in that 35th year. So we just plug all this in. 43,000 times the ratio. Since it's a growth problem, we have to do basically 100 plus 3%, then move it over 2 decimal places. So we'd have 1.03 to the n minus 1, which would be 34. So now we can just refer back to our calculator again and see what we get. So I'm going to type that in. 43,123,000 times 1.03 to the 34th power. So it looks like she is going to make about $117,000. Apparently I don't have that option, so hopefully on your handout it's got the answers A, B, C, and D on it printed out. So 117,472. So that would be how much she makes in her 35th year.